The year was 1940. The B-24 Liberator was not just an airplane, it was the most complex machine ever conceived for mass combat. It was a four-engine heavy bomber weighing 56,000 pounds. It had a wingspan of 110 feet. Inside its aluminum skin were 360,000 individual rivets and over 1.2 million constituent parts. It was designed by Consolidated Aircraft in San Diego, a company that treated the construction of a bomber like the construction of a custom yacht. In 1940, Consolidated was building these leviathans outdoors under the California sun. Highly skilled craftsmen would stand on scaffolding, filing parts by hand to make them fit, reading complex blueprints, and slowly, painstakingly, assembling the fuselage rivet by rivet. At their absolute peak efficiency, they could finish perhaps one plane a day. Then came the order from Washington. The Roosevelt administration didn't want one plane a day. They wanted 50,000 planes a year. The aviation industry said it was impossible. They argued that a bomber was not a car. It required tight tolerances, specialized aerodynamics, and constant design changes. You couldn't just stamp them out like fenders. The critics, generals, politicians, and aviation experts agreed that the complexity of the B-24 made mass production a fantasy. They were about to be proven wrong by a man who hated the word impossible. His name was Charles Sorensen, the production chief of the Ford Motor Company, and he was about to turn a quiet patch of Michigan farmland into the single greatest industrial room in the history of the world. This is the story of Willow Run.
To understand why the critics were so skeptical, we have to look at the state of American manufacturing in January 1941. There was a hard line between the automen of Detroit and the airplane men of California. The airplane men believed in soft tooling. Because aircraft designs changed constantly to keep up with enemy technology, they used temporary dies and hand-forming techniques. This allowed flexibility, but it killed speed. Every part was slightly unique. A door from one B-24 wouldn't necessarily fit on another B-24 without a mechanic attacking it with a file and a hammer. The automen, led by Ford, believed in hard tooling. They spent months building massive, permanent steel dies that could stamp out a fender with zero variance millions of times in a row. But once that die was made, you couldn't change it. When the government asked Ford to help Consolidated build the B-24, Charles Sorensen traveled to San Diego to see how the aircraft experts did it. What he saw horrified him. He later wrote, "I saw a situation that to my mind was chaotic. I saw men filing parts to make them fit. It was a cobbler's job, not a manufacturer's." Sorensen stood looking at the fuselage of a B-24, which was split into a forward and aft section. He realized the problem wasn't the plane, it was the method. The aircraft company was building the plane from the keel up, like a house. Sorensen knew the only way to get to 50,000 planes was to build it like a Model T, in motion.
That night, in his room at the Hotel Coronado in San Diego, Sorensen didn't sleep. He took a piece of hotel stationery and began to sketch. He drew a factory floor plan that defied logic. It was an L shape, nearly a mile long. He sketched out a system where the B-24 would be broken down into 70 distinct subassemblies. The wings, the fuselage, the nose, the tail, all built on separate feeder lines, converging onto a massive main line where the plane would be mated together in a continuous flow. He calculated the timing. To meet the government's demand, the final assembly line would need to move the massive bomber forward one station every hour. When he presented the plan, the Consolidated engineers laughed. They told him a B-24 had 30,000 distinct design changes a year. Hard tooling a bomber would freeze the design, they argued. By the time Ford built the dies, the plane would be obsolete. The critics called it a boondoggle,
They said Ford was trying to apply tractor logic to aerodynamics. Sorensen didn't care. He returned to Detroit and told Henry Ford, "We can do it." The site chosen for this experiment was a 975-acre farm owned by Henry Ford near Ypsilanti, Michigan, crossed by a small stream called Willow Run. Ground was broken on April 18, 1941. The scale of the construction was biblical. The factory building itself would cover 3.5 million square feet, the largest room ever built by man at that time. It required 39,000 tons of structural steel. The floor was so vast that supervisors were eventually issued cars just to get from one end to the other. But the building was the easy part. The nightmare was the tooling.
Ford engineers had to translate 30,000 aircraft blueprints into automotive specifications. They discovered a critical problem. Aluminum is not steel. When you stamp a steel car fender in a massive press, the metal stays where you put it. When you stamp aluminum, it possesses springback. It tries to return to its original shape. The Ford engineers had to calculate the springback of every single rib and bulkhead, redesigning the steel dies to overbend the metal just enough so that it would spring back to the perfect tolerance. It was a mathematical headache that consumed thousands of man-hours. Throughout 1942, the critics seemed to be right. The plant was plagued by issues. The sheer size of the factory created its own weather systems. In the mornings, haze and fog would form inside the high bays. Worse, there was a labor crisis. The plant was located 30 miles from Detroit. There was no housing, no infrastructure, and gas was rationed. Workers were living in tents, trailers, and shacks in the Michigan winter. Turnover was catastrophic. In 1 month, Ford hired 2,900 new workers, but 3,000 others quit, and the planes weren't coming out. By the summer of 1942, the plant that was supposed to save the world had produced only a handful of complete aircraft. The Washington critics turned savage. They nicknamed the plant "Will It Run?" They accused Ford of wasting hundreds of millions of taxpayer dollars on an ego project. The Truman Committee launched an investigation. The soft tooling advocates said, "We told you so." They said a bomber was simply too complex to be put on a chain and moved. They said the precision required for high-altitude flight could not be achieved by a farm boy or a housewife spot welding a fuselage section in 40 seconds.
But Charles Sorensen and his production chief, Meade Bricker, ignored the noise. They knew something that critics didn't. They knew about the learning curve of hard tooling. In mass production, the front-end setup is grueling. You spend months or years setting up the jigs, the fixtures, and the dies. During this phase, output is zero. It looks like failure. But once the system is calibrated, once the bugs are worked out of the dies, production doesn't just increase linearly, it explodes exponentially. The turning point was the center wing section. This was the heart of the B-24. It was a massive 56-foot span that carried the engines, the landing gear, and the bomb racks. It was the most difficult structural component of the war. Consolidated built it vertically in a stationary buck, with workers climbing ladders to rivet it. Ford built it horizontally. They created a massive machining tool, the Ingersoll transfer machine, specifically for this part. It was a distinct automotive approach. The raw aluminum spar would enter the machine, and a series of automated drills and mills would perform 45 simultaneous operations, drilling hundreds of holes to within a thousandth of an inch tolerance in seconds. What took Consolidated days to do by hand, Ford began to do in minutes.
By 1943, the bugs were dying. The hard tooling was finally dialed in. The workforce, now stabilized and swelled by thousands of women, the famous Rosies, began to find their rhythm. The factory was divided into villages.
There was a village for the forward fuselage, a village for the tail, a village for the engines. Each village operated on a precise clock. At the mating station, the magic happened. The center wing section was lowered by a crane. The forward fuselage and aft fuselage were rolled in on carts. The engines were lifted into place. In early 1943, the line started to move, slowly at first, then faster. The critics who mocked Willow Run went silent as the numbers began to climb. In January 1943, output was 30 planes. By June, it was 150. By December, Ford was producing nearly 300 bombers a month. But the peak, the ultimate vindication of the automotive method, came in 1944. By then, Willow Run was a singular organism. It consumed 1,600 tons of aluminum alloy every single day. It used 400,000 rivets an hour. The assembly line, known as the Mile, was a relentless river of silver metal. The Ford engineers had achieved absolute interchangeability. A pilot could take a rudder from a Willow Run B-24 and bolt it onto a consolidated B-24 built in San Diego, and the bolt holes would line up perfectly. This was a feat of manufacturing engineering that the Germans and Japanese never fully mastered. Then came the record.
The goal had been one bomber an hour, one plane every 60 minutes. It was a number considered theoretically impossible for a four-engine heavy bomber. In the spring of 1944, the line hit its stride. The overhead conveyors moved with hypnotic regularity. The sound of the factory was a deafening, continuous roar of rivet guns, a sound described by workers as the heartbeat of the arsenal. They didn't just hit the goal, they shattered it. At its absolute peak, Willow Run was completing one B-24 Liberator every 63 minutes on a sustained basis. During one specific 9-hour shift, they rolled a plane off the line every 55 minutes. Let's put that into perspective. A B-24 Liberator is a 30-ton war machine. It has 4 1,200 horsepower Pratt & Whitney engines. It has miles of hydraulic lines, miles of electrical wiring, oxygen systems, intricate bomb sights, and 10 .50 caliber machine guns. And Ford was birthing one of these monsters in the time it takes to eat a lunch break. By 1944, the problem wasn't building the planes. The problem was flying them away. The tarmac outside the factory couldn't hold them. The Army Air Forces had to construct massive dormitories for the ferry pilots who arrived daily to take the bombers to England and the Pacific. At one point, the output was so high that the Air Force simply couldn't accept them fast enough, and the silver planes were parked nose to tail for miles, a ghost army waiting for crews.
By the time production ceased on June 28, 1945, Willow Run had built 8,685 B-24 Liberators. That is nearly half of all the B-24s ever built. To visualize that number, imagine a line of bombers wingtip to wingtip. The line of planes built at this single factory would stretch for over 180 miles. The critics had been right about one thing: a bomber wasn't a car, it was harder. But they were wrong about the capability of American industrial engineering. They underestimated the power of hard tooling when applied with ruthless determination. The cast-iron men of Detroit didn't just build planes, they broke the spirit of the Luftwaffe. When German armaments minister Albert Speer was interrogated after the war, he admitted that it wasn't the American soldiers that terrified the German high command, it was the American production figures. They knew that no matter how many planes they shot down, Willow Run was printing another one every 63 minutes. The secret plant that critics said wouldn't run became the ultimate symbol of the industrial war. It proved that in the 20th century, the front line wasn't just on the beaches of Normandy or the islands of the Pacific. The front line was in Ypsilanti, Michigan, on a mile-long assembly line where the impossible was made routine, 1 hour at a time. If you enjoyed this deep dive into the industrial precision of World War II, hit that subscribe button. Next week, we're uncovering the truckers who saved the Allied advance, the Red Ball Express. You don't want to miss it.